Hello world, last time we talked about unique pointer, and the big thing about unique pointer is that it should be unique. So you should only have one unique pointer pointing to an address. Otherwise you're probably going to have a double delete. So it makes sense that the copy constructor and the copy assignment operator for the unique pointer are deleted, right? But what if we really wanted to copy it? What if there was an object and I need many pointers pointing at that object, but then I don't know which one will go out of scope first, so I don't have a single owner of that pointer to delete it. So what can I do to make sure that the pointer gets deleted exactly once? Remember, if it doesn't get deleted, it's a memory leak. But if it gets deleted twice, it's a double delete. So we want exactly one delete for that object. So what we can do is we keep a count of how many pointers are pointing to that object. And when that count reaches 0, meaning no one is pointing at that object, we call delete. Let's try to build that today, and I came up with a name for it. It's pretty original. I will call it shared pointer. We will base the implementation of our shared pointer on the implementation that we've already done for the unique pointer. So we'll just copy and paste it for now, and then we'll edit it. So here I have the unique pointer we wrote, and right below we have our make unique, and then the shared pointer, and then make shared. So of course both implementations are the same right now, and we're gonna change that. My idea for counting the shared pointer is whenever I construct the pointer, I'll just set a count to 1. And then when I copy the pointer, I will increment the count. And when I destruct the shared pointer, I will decrement the count. And then if the count is 0, I will delete the pointer. Sounds reasonable, right? I will write here a quick implementation that will not work. And let's see it. This copy constructor shouldn't even compile, because if you see right there, we're incrementing the other.count, but we said that other is a const reference, so we cannot be messing with it. Of course we know that in C++ const is not immutable, we can just change it, but let's not do that. But then there's another problem as well. Just to show what the other problem is, let's just remove const for now. And now let's test our copy constructor. It works. So when I gets constructed, it has a count of 1. When it gets copied into J, the count increments to 2, and J's count is also 2. Then the print function happens, and then J gets destructed, its count is decremented to 1, and then I gets destructed, and its count is decremented to 1 because it's 2. So you see the problem there is that the count is copied, but to its own value. We should have them both have the same value always. And there's an even bigger problem if I have something like this. So if I have this, then as before, J's count is 1, But when k gets copy constructed by I, i's count is incremented to 3, k's count is 3 as well, but j's count is still 2. So that's a whole mess. So we need to have all shared pointers that share the same pointer pointing to the same count. So how do we do that? How do we have a bunch of objects sharing the same value? We use a pointer, of course. I think this line here is pretty unclear. It says bang minus minus star count, but let's leave it like this. I think it works. So now we have a pointer to an int, which will pass into the constructor, because we don't want to be calling new inside the constructor. We'll just use new in MakeShared. For now, we'll just pass the count into the constructor, and it's the user's responsibility to pass a 1 there, okay? The user should just use MakeShared. Now that we have a new member in our class, we should update the move constructor and the move assignment operator, and we'll just take this chance and also write the copy assignment operator. For the assignment operator, I'm creating a copy, just so I don't have to repeat myself. That already copies the members and updates the reference count. And then I'm swapping the values with the... Oh, now that I see it, I wrote it wrong. And then I'm swapping the values of this copy with my own. So the copy gets my values, but it's going to get destructed soon. And I get the values from the copy, which are copied from the other. Okay. Now, there's a lot of repetition here with these swaps. These two lines get repeated 3 times. So this time I think it makes sense to create a swap member function. And also, those two assignment operators look pretty similar. If we just remove the reference, I think they'll be quite the same. I think that's the same behavior we had before. We cannot be sure yet that the shared pointer is working. We'll only know that when we write the unit tests with Google Mock and everything, but that will be another day. But I'm not even confident that this is working. I'll just quickly write a class that yells something when it's deleted, and then we'll just do some crazy things and check if it gets deleted once. That will be our test for today. As always, I forgot to write public. I'll just make it a struct. Oh man, it says here no matching function for call to swap. Let's see what happened. Okay, so when it calls swap, it cannot find std swap. Let's see why. So if you see here, the type that swap is using for the template is yelling class star const. Where does this const come from? Well, when I created the swap member function, I didn't pay attention and the IDE just put a bunch of const there and I didn't notice. So let's change that. Okay, this is better. Okay, now everything works. We're just getting a 6seg-v. Let's investigate this a little bit. Let's run it in debug mode and see what's happening line by line. Okay, so first of all we have I, and everything looks good. The pointer is pointing somewhere, the count is pointing somewhere with a value of 1. Now the count got incremented to 2, and J is also pointing to the same stuff, okay. K is also pointing to the same stuff, and now I is pointing to null pointer. And now let's take a look at what happens with the destructors. So this is of course the destructor for K. The count goes to 1. Now the destructor for J, the count is 1 and goes to 0, so it goes there and deletes. Okay, good. And now for I, remember we set everything to null pointer. So what happens? When it tries to decrement the count, we get the 6seg-v. So I think the easiest way to fix this is, instead of having the count initialized to null pointer, we initialize it with a value of 1. Let's see what that would entail. Now we don't need this. The new there is bothering me a little bit because new can throw. We shouldn't have it there. We could put it in the initializer list and put a try-catch block there. Did you know that you can put a try-catch block in the initializer list? Let's do it just for fun. I think it goes here. And then you can catch it here and do whatever you want. Also, you would have to do this for the other constructors, the copy constructor and the move constructor. The other way to get around this is to leave the code as it was before with the new inside make shared. And then in the destructor just check for null pointer. So which one do you prefer, or is there a third way that I didn't think about? Tell me in the comments, please. And now let's just play a little bit more with this and see if it works. Good. Now I think I'm calling everyone. I'm calling the constructor, then I'm calling the copy constructor, then I'm calling the move constructor, then the constructor again, then the copy assignment, and then the move assignment, and then a bunch of destructors. All this time we created 2 instances of yelling class, and it's yelling twice, saying it got deleted. So I think we did a pretty good job. Of course, this is not some unit test, it's just a random test. But we'll get to unit tests later. First we gotta finish this and see the weak pointer. I'll see you next week.
Hello, world. I hope you enjoyed watching me almost fall asleep while the sun rises. Anyway, I forgot 2 very important things. One of them caused a memory leak. Can you figure it out? The other thing I forgot to say, this is lacking all the stuff that our unique pointer is lacking, plus one big feature. The standard library's shared pointers count is thread safe, while ours is not. This is relevant if you want to use STD shared pointer in a multi-threaded context.
Bye, world.